All right, this video is going to cover 2.5a, polynomial equations and equations in quadratic form. So solve the following polynomial equation, enter the solution using a comma-separated list. We have 4d to the 6th power minus 100d to the 4th power equals 0. This is already in standard form, so that's great. Standard form, remember, is set equal to 0. So now we need a factor. Our first step in factoring, no matter what, is GCF. So looking at 4d to the 6th minus 100d to the 4th, they both have a 4 in common, and they both have at least d to the 4th in common. So 4d to the 4th would be our GCF. So we can factor or divide out 4d to the 4th from both terms. So taking out that 4d to the 4th, 4 divided by 4 cancels out or goes to 1. D to the 6th divided by d to the 4th. We have 6 d's. We are dividing or taking out 4 of them. That means we have 2 d's left over, so d squared minus 100 divided by 4 would give us 25. D to the 4th divided by d to the 4th cancels out. So we're left with d to the 4th, 4d to the 4th times d squared minus 25. So if you notice, d squared minus 25 is a difference of perfect squares. Difference of perfect squares. So we can factor that down. D squared is d times d. One's positive, one's negative. 25 is 5 times 5. So we factored that. Bringing down that GCF of 4d to the 4th out front equals 0. So now we can set each factor equal to 0 and solve. So 4d to the 4th equals 0. D plus 5 is 0. And d minus 4 equals 0. I'm sorry, d minus 5. I was thinking about getting rid of that 4 over there. So starting off, 4d to the 4th equals 0. We can divide both sides by 4. We're left with d to the 4th equals 0. Getting rid of that 4th power, we could take the 4th root of both sides. That way the 4th power and the 4th root cancel each other out. We're left with d equals the 4th root of 0, which is 0. D plus 5 equals 0. We could subtract 5 from both sides. We're left with d equals negative 5 as our next answer. Over here, d minus 5 equals 0. We can add 5 to both sides, and we're left with d equals positive 5. So our answers are 0, negative 5, and positive 5. Next one says solve the following polynomial equation by factoring. Enter the solutions using a comma-separated list. 8k squared minus 36k equals negative 4k cubed plus 72. So we want to put this in standard form. We want to get it set equal to 0 and putting it in descending order. So let's move that negative 4k cubed to the other side so I can add 4k cubed to both sides. That way those cancel. Move that 72 over by subtracting 72 from both sides. So I want to put it in standard form. Which is set equal to 0 and in descending order. Meaning I want to put it in the right order with the exponents. So meaning that 4k cubed is going to come out front. So that's the highest exponent. Next I have a positive 8k squared minus 32k minus 72 equals 0. So now that it's in standard form set equal to 0, I can factor. Looking at all 4 terms, I see that they all have a 4 in common, so our GCF would be 4. So I can factor or divide out a 4 from all 4 terms. So bringing that 4 out front, we're left over with k cubed plus 2k squared, negative 32 divided by, I'm sorry, this is a 36, not a 32. Negative 36 divided by 4 will give us negative 9k. then negative 72 divided by 4 would give us negative 18 equals 0. So now 4 is done. Now we have 4 terms, so now we can factor by grouping. Now we can factor by grouping. Meaning that 4 is done, I'm just going to kind of hide it for a minute. I can group my first two, group my last two. Looking at our first two terms, k squared plus 2k squared, they both have a k squared in common, so I can factor or divide out k squared. That 4 is out front, it's going to stay out front, I'm just going to bring it down. Then we're bringing out a k squared, we're left over with k plus 2. Looking at our next two terms, negative 9k minus 18, I can factor or divide out negative 9 from both terms at GCF. In doing so, we're left over with k plus 2 equals 0. We know we did it right because they both have k plus 2 in common. So we're going to bring that 4 down just so we don't forget it. They both have a k plus 2 in common, so that'll be our GCF. Taking that 4 out, taking the k plus 2 out, we're left over with k squared minus 9 equals 0. So looking at k squared minus 9, I know I can factor that further. So let me bring this up here. I'm just going to rewrite it. So 4 times k plus 2 times k squared minus 9 equals 0. So I have 4 times k plus 2. I can factor k squared minus 9. It's another difference of perfect squares, so I can factor that further because of k squared, I need to try to factor it. K squared is k times k. One's positive, one's negative. 9 is 3 times 3. So we factored it completely. So now we can set each factor equal to 0 and solve. So 4 equals 0. I'm trying to find what k equals. That doesn't tell me what k equals. There's no k there, so I don't care about that one. Next we have k plus 2 equals 0. We could subtract the 2 from both sides, and that will give us k equals negative 2 as one answer. Next we have k plus 3 equals 0. Subtracting 3 from both sides, we get k equals negative 3. That's done. Then we have k minus 3 equals 0. Adding 3 to both sides, we get k equals positive 3. So our answers are negative 2, negative 3, and positive 3. You can pause this video, you can rewind, you can fast forward, you can slow my voice down, you can speed it up. I don't know how you can speed it up, but here's your answer. Let's go on to the next one. It says solve the following polynomial equation, enter solution using comma separated list. 2k cubed plus 5x, sorry, I'm thinking of k over here. 2x cubed plus 5x squared plus 200x plus 500 equals 0. It's already in standard form for us. It's already set equal to 0, so that's good to go. So next we need a factor. Our first step in factoring is GCF. They all have a 2 in common, so we could factor out that GCF of 2. I can't do a GCF of 2 because of my 5. JK. Just kidding. There is no GCF. There's nothing that all 4 terms have in common, so no GCF. So I have 4 terms, so now I can factor by grouping. So now group the first 2, group the last 2. Looking at our first 2 terms, 2x cubed plus 5x squared, they both have x squared in common, so I can factor or divide out that x squared. In doing so, we're left over with 2x plus 5. Looking at our next 2 terms, we have 200x plus 500. They both have 100 in common, so that'll be our GCF. We're taking out a positive 100. We're left with 2x plus 5 equals 0. We know we did it right because they both have 2x plus 5 left over, so that will be one factor. And we're left over taking those out with x squared plus 100. Now this looks like a difference of perfect square, but difference means subtracting 2 perfect squares. This time we're adding, so it's not a difference of perfect squares. Adding, so not difference of perfect squares. So that means we cannot factor. So we're going to solve using our square root property. Adding, so it's not a difference of perfect squares, so we cannot factor it, so we're going to have to solve it using the square root property. So setting each factor equal to 0, we get 2x plus 5 equals 0. Getting x by itself, we can subtract 5 from both sides. We get 2x equals negative 5. Dividing both sides by 2, we're left with x equals negative 5 over 2. That's done. And then over here, we have x squared plus 100 equals 0. So getting x by itself, let's get rid of this 100 so we can subtract 100 from both sides. We're left with x squared equals negative 100. Getting rid of that squared, we could take the square root of both sides. That way the square and the square root cancel each other out. We have x equals, we took the square root, so don't forget, plus or minus. The square root of 100 is 10. The square root of that negative is I. So we have plus or minus 10i. So using a comma separated list, positive 10i, negative 10i. And then we have our negative 5 over 2 as well. Don't forget plus or minus. All right. So next page. Solve the following equation. Solve the following polynomial equation. Enter the solutions using a comma separated list. There we go. Negative 3k to the 5th equals 24k squared. We always want to put it in standard form, so let's get move everything to one side. I'm going to move this negative 3k to the other side just so that way it's positive. Doesn't matter what side. So adding positive 3k to the 5th to both sides to put it into standard form. Which remember is set equal to 0. So we have 0 equals 3k to the 5th plus 24k squared. So it's set equal to 0, so we can go ahead and try to factor it. So looking for a GCF. 3k to the 5th and 24k squared both have a 3k squared in common. They both have a 3 in common, and they both have k squared in common. So we can factor or divide out 3k squared from both terms. We have 0, bringing that 3k squared out front. We're left over with k to the 3rd power plus 8. 24 divided by 3 is 8. Our k's cancel out. So 3k squared is good, but we have k cubed plus 8. Notice we are adding now, instead of perfect squares, we have perfect cubes. So remember, we had our cubes formula back in intermediate algebra or algebra 2. So we're adding, so we're going to use our sum of cubes formula, which says a cubed plus b cubed equals a plus b times a squared minus ab plus b squared. We're adding, so we're going to use that sum of cubes formula, but just so that way you have it here. If you're subtracting, remember it's a difference of cubes, which if you had a cubed minus b cubed, that would give you a minus b times a squared plus ab plus b squared. So those are those two formulas that you will have to know for the test. All right, so here for a cubed plus b cubed, kind of working backwards, here we have k cubed plus 8, which would be 2 cubed. So a is k, b is going to be 2. So wherever I see an a, unplug in k, wherever I see a b, unplug in 2. So k plus 2 times k squared minus k times 2 plus 2 squared. So again, working up instead of down, we have k plus 2 times k squared minus 2k plus 2 squared will give us 4. So you factored this thing. So we have 0 equals 3k squared, just bringing this down. Then we factored it into k plus 2 times k squared minus 2k plus 4. All right, so now we have it in factored form. By the way, this, whenever we plug this in, whenever it's from these difference of cubes, this last thing is never factorable. So don't even waste your time. We know it's not going to be factorable. So that means we're going to use, it's a quadratic, it's x squared, or in this case, k squared. So we're going to use the quadratic formula. All right, so before we do that, setting each factor equal to 0, 3k squared equals 0. Getting k by itself, we could divide both sides by 3. K squared equals 0. Taking the square root of both sides. Those cancel. We're left with k equals 0. Then we have k plus 2 equals 0. Subtracting 2 from both sides. We're left with k equals negative 2. And then we're left over with k squared minus 2k plus 4 equals 0. We said it's not factorable, so we're going to use a quadratic formula. So a in front of k squared is positive 1, b in front of k is negative 2, c out by itself is positive 4. Remember, our quadratic formula says in this case k instead of x. Negative b plus or minus the square root of b squared minus 4ac all over 2a. So we have negative 2 plus or minus the square root of negative 2 squared minus 4 times 1 times 4 all over 2 times 1. Negative 2 would give us positive 2 plus or minus the square root of that stuff. I can plug that stuff into my calculator just like I see it. In parentheses, negative 2 squared, oops, minus 4 times 1 times 4, and we get negative 12. Oops. Over 2. We always want to simplify, so let's simplify that square root of negative 12 real quick. I'm running out of room. We get negative 1 times 12. Negative 1 is our special case, so it gets circled. 12 is 2 times 6. 2 cannot be broken down any further, so it gets circled. 6 is 2 and 3. Again, 2 and 3 cannot be broken down any further, so they get circled. So underneath our square root, we have negative 1 times 2 times 2 times 3. The square root of negative 1 is our special case, that's I. It's the square root, so we're looking for 2 of a kind, so those 2 2's are coming out. And that poor little lonely 3 is left by itself underneath the radical, so we're left over with 2i square root of 3. So I have 2 plus or minus 2i square root of 3 all over 2. So both terms will be divided by 2. So 2 divided by 2 would give me 1. Plus or minus my 2's would cancel out. I square root of 3. So we have 1 plus I square root of 3, comma 1 minus I square root of 3. So I have root 2 big and but that's our answer. All right, let's keep going. So it says solve the following polynomial equation, enter the solution using a comma separated list. Remember, you can pause at any time, rewind, fast forward, all that good stuff. Z to the fourth equals 8z squared minus 20 equals 0. So first of all, this is in standard form already, so that's good. In standard form, it's set equal to 0, so that's done. Now it looks super similar to factoring. The difference is, though, instead of like our normal ax squared plus bx plus c, we have different. Instead of x and x squared, or z and z squared, we have z squared and z to the fourth. So we can use what's called U substitution. Use U substitution. We call it U sub sometimes. Use U sub. So what this is saying is we're going to plug in u instead of z to make this a little bit easier for us. So bear with me for a minute. We're going to let u equal z squared. It's always going to be that middle term, that middle variable. So we're going to let u be z squared. If u is z squared, then if you take u squared, squaring both sides, that means u squared would be z to the fourth power. If we square both sides, that would tell us that u squared is z to the fourth power, which is this first one. It should always be this first one. If it's not, you did it wrong, so go back and check your work. So now plugging that in, again, we're going to plug in u just to help make this easier for us to factor like a normal equation. So instead of z to the fourth, I can write u squared, because u squared equals z to the fourth, minus 8. Instead of z squared, I can write u minus 20. I'm just plugging in those things. And I just made it up and said let u equal this middle variable. And if I square this middle variable, I would get u squared and I would get z to the fourth power. So now this is a normal factoring problem. So now I can factor like normal. U squared minus 8u minus 20 equals 0. There's no GCF. A in front of u squared is going to be positive 1. B in front of u is going to be negative 8. C out by itself is negative 20. So we're looking for two numbers that multiply together to give us a times c, 1 times negative 20, which is negative 20. And the same two numbers to be added together to give me b, which is negative 8. Negative 10 and positive 2. Negative 10 times positive 2 is negative 20. Negative 10 plus positive 2 is negative 8. Thankfully, a is 1, so we can use our shortcut. Our shortcut says we can go straight to our two factors. Equals 0. The variable that we're using is u. And my blank is negative 10, so it'll be u minus 10. And my next blank is positive 2, so it'll be u plus 2. So now we can set each factor equal to 0. So u minus 10 equals 0, and u plus 2 equals 0. And get u by itself. We can add 10 to both sides. So we get u equals positive 10. We can subtract 2 from both sides. So we get u equals negative 2. That's great. I found u, but the problem had nothing to do with u. We just used u to help us make this easier for us to factor. So let's plug in our z's back in. All right, so coming up here. So if we know u equals 10 and u equals negative 2, we know u, bringing our z's back in, is the same thing as z squared. So we know z squared has to equal 10. And z squared has to equal negative 2. All right, so getting z by itself, getting rid of that squared, I could take the square root of both sides. That way the square and the square root cancel each other out. Remember, whenever you take the square root, don't forget plus or minus. So we have z equals plus or minus the square root of 10, which would be positive square root of 10 and negative square root of 10. So those are two answers. Over here are other two answers. Z squared equals -2, taking the square root of both sides. That way our square root and our square cancel each other out. We are left over with Z. We took the square root, so plus or minus. The square root of -2, I know that negative is going to come out as an I, and then the square root of 2. I can't simplify the square root of 2, so we're just going to leave it like that. So that would give us positive I square root of 2, comma negative I square root of 2. And let me not box this one in, and then I'll put in one answer at the very end. So our final answer is putting it all together. So we have the square root of 10, negative square root of 10, positive I square root of 2, comma negative I square root of 2. So those would be our 4 answers. That's how I put it into the homework. Let's do another one of these U subs. So solve the following polynomial equation, enter a solution using a comma separated list. X minus the square root of x minus 30 equals 0. So it's in standard form, it's set equal to 0, so that's good. We always want to try to factor. That's kind of like our go-to. This looks kind of similar to factoring, but not really. So let's use the U sub to help set the equation up to make it easier for us to factor. So we're going to let U equal this middle variable, so the square root of x. Always the middle variables. So it's going to be square root of x. So if I have U equals the square root of x, if I were to square both sides, the square root and the square cancel each other out. So we know U squared is just x. So U squared is just x. So x, instead of x in the problem, I can rewrite it as U squared minus the square root of x, which I can rewrite the square root of x as U, minus 30 equals 0. So now we can factor it just like normal. U squared minus U minus 30 equals 0. There's no GCF. Our A value in front of U squared is 1, B in front of U is -1, C out by itself is -30. So we're looking for two numbers that multiply together to give us A times C, 1 times -30, which is -30, and the same two numbers to add together to give me B, which is -1. So -6 times +5 would give us -30, and -6 plus 5 would give us -1. Thankfully, our A value is 1 again, so we can use our shortcut again. Our shortcut tells us we can go straight to our two factors set equal to 0. The variable that we're using is U. In my blank is -6, so one factor is U minus 6, and my next blank is +5. So my other factor is U plus 5. Setting each factor equal to 0, so U minus 6 equals 0, U plus 5 equals 0. Solving each one separately, we can add 6 to both sides, and we get U equals +6. We can subtract 5 from both sides, and we get U equals -5. But then coming up here, U equals 6 and U equals -5. U was not in the problem. We just used it to help us factor more easily. So instead of U, I know U is the same thing as saying the square root of x. So instead of U, I can write the square root of x equals 6. Instead of U, I can write the square root of x equals -5. So let's solve for x. Let's get x by itself. The opposite of square root is squaring, so we can square both sides. That way the square and the square root cancel each other out. We're left over with x equals 36. Same thing over here. We can square both sides. Square root and square cancel each other out. We're left over with x equals -5 squared, so -5 times -5 is +25. Because we have a square root in the problem, we have to check our answer. So because there's a radical in the problem, we need to check our answer. So checking, just plugging in +36. So 36 minus the square root of 36 minus 30 equals 0. So we have 36 minus 6 minus 30 equals 0, which will give us 0 equals 0, so that works. Likewise, let's check 25. So 25 minus the square root of 25 minus 30 equals 0. So 25 minus 5 minus 30 equals 0. 25 minus 5 minus 30 will give me negative 10. Negative 10 does not equal 0. So 25 does not work. 36 is the only one that works. That is our only answer. All right, so next page. Last page. 3 more pages. Almost done. Solve the following equation and other solutions using a comma separated list. 3x to the 2/3 power minus 4x to the 1/3 power minus 15 equals 0. This is in standard form, so we're good to go. It's set equal to 0. So we can let u, it looks similar where we can factor it, but it's just a little bit ugly. So to make it look better, let's use u instead of this crazy fraction exponent. So let u equal this middle variable, so x to the 1/3 power. If u equals x to the 1/3 power and we were to square both sides, multiplying power to a power, you're going to multiply your powers. 1/3 times 2 would give us x to the 2/3 power. It should always be this first variable. So now let's plug it in. We have 3x to the 2/3 power. X to the 2/3 power is the same thing as u squared. Minus 4x to the 1/3 power, which is the same thing as u. Minus 15 equals 0. So now we can factor like normal. Looking at u squared minus 4u minus 15, there's no GCF. So because there's no GCF, you can say A is positive 3, B is negative 4, and C is negative 15. So we're looking for two numbers that multiply together to give us A times C. So 3 times negative 15, which would give us negative 45. And the same two numbers to add together to give us B, which is negative 4. So negative 9 and positive 5 multiply together to give us negative 45 and add together to give us negative 4. Unfortunately, A is not 1, so that means we have to factor by grouping. No shortcut here. Unfortunately. So we have to factor by grouping, no shortcut. So that means we have 3u squared. Instead of our middle 4u, we're going to use the numbers in our blanks to split up that middle b term. So instead of negative 4u, we have negative 9u and positive 5u. Negative 9u plus 5u is still negative 4u. Just split it up using the numbers in our blanks. Minus 15 equals 0. So now I have 4 terms. So now I can group the first two, group the last two. Looking at our first two terms, 3u squared minus 9u. Let's factor divide out our GCF of 3u. We're left over with u minus 3. Looking at our next two terms, 5u minus 15, let's factor out our GCF of positive 5. We are left over with u minus 3 equals 0. We know we did it right because they both have u minus 3 in common, so that'll be one factor. Okay, that'll be one factor. Taking those away, we're left over with 3u plus 5, and that'll be our other factor. Equals 0. So u minus 3 equals 0 is one factor. We're going to set it equal to 0. 3u plus 5 equals 0. We're going to set that factor equal to 0, and we're going to solve separately. So let's add 3 to both sides. We're left with u equals positive 3. And then over here we can subtract 5 from both sides. We get 3u equals negative 5. Dividing both sides by 3. We get u equals negative 5/3. Okay, so we solve for u, but the question didn't ask us to solve for u, it asked us to solve for x. So let's plug in our x's back. So instead of u, I know u is the same thing as x to the 1/3 power. So x to the 1/3 power instead of u equals 3. And x to the 1/3 power instead of u equals negative 5/3. So we need to get rid of this 1/3 power. So in order to get rid of that 1/3 power, I want to raise those sides to the 3rd power. That way my 3's cancel. So we just want that to do together. So we're left with x equals 3 cubed, 3 times 3 times 3, which is 27. That's my answer. Same thing over here, x to the 1/3 power. If I cube both sides, the 3's cancel. And we multiply your exponents. And you're left with x equals negative 5 cubed divided by 3 cubed. So negative 5 times negative 5 times negative 5 is negative 125. All over 3 times 3 times 3, which is 27. So negative 125 divided by 27. All right, so let's do the next one. So solve and check. K minus 2 squared plus 3 times k minus 2 minus 4 equals 0. Thankfully, this is in standard form. It's set equal to 0. So let's go ahead and plug u in. So we're going to let u equal this middle variable, so k minus 2. That way u squared would be k minus 2 squared, which is that first variable. So k minus 2 squared is going to be our u squared, so u squared plus 3 times k minus 2 is u, minus 4 equals 0. So now we can factor it like normal. There is no GCF. Our a value in front of u squared is positive 1. Our b value in front of u is positive 3. Our c value out by itself is negative 4. We're looking for two numbers that multiply together to give us a times c. So 1 times negative 4, which is negative 4. And the same two numbers to add together to give me b, which is positive 3. So positive 4, negative 1. 4 times negative 1 is negative 4. 4 plus negative 1 is positive 3. Thankfully, our a value is 1, so it'll save us some time. So we can use our shortcut. Our shortcut says we can go straight to our two factors, set equal to 0. The variable we're using is u. The numbers in our blank are positive 4, so that factors u plus 4. The other number in my blank is negative 1, so that factors u minus 1. I'm going to come up here so I have more room. So we have to set both factors equal to 0, so u plus 4 equals 0, and u minus 1 equals 0. Getting u by itself, we can subtract 4 from both sides, and we get u equals negative 4. Over here, we can add 1 to both sides, and we get u equals positive 1. So we got u by itself, but the problem didn't ask for u, it asked us to solve for k. We know u is the same thing as saying k minus 2, so I can substitute or plug that back in. So u is the same thing as saying k minus 2. So k minus 2 equals negative 4, and k minus 2 equals positive 1. Now getting k by itself, we can add 2 to both sides. So that means k equals negative 4 plus 2. So k equals negative 2. And then k minus 2 equals 1. Adding 2 to both sides, we get k equals 3. Last one. So solve the following rational equation. Remember, rational means fraction. Enter the solution using a comma-separated list. 1 over y squared minus 1 over y minus 6 equals 0. So let's let u equal 1 over y. And that means u squared would be 1 over y squared. And if you square the top, square the bottom, that would give us 1 over y squared, which is this first variable. So 1 over y squared is the same thing as saying u squared, minus 1 over y, which is the same thing as saying u, minus 6 equals 0. So u squared minus u minus 6 equals 0. By the way, it's in standard form just to stay consistent. It said equal to 0, so that's why we were good to go. So now we can factor. Our first step in factoring is GCF, but there's nothing that u squared minus u minus 6 have in common. So our a value in front of u squared is positive 1, b in front of u is negative 1, c out by itself is negative 6. We're looking for two numbers that multiply together to give us a times c, 1 times negative 6, which is negative 6. And the same two numbers to add together to give us b, which is negative 1. And we have negative 3, positive 2. Negative 3 times positive 2 is negative 6. Negative 3 plus 2 would give us negative 1. Thankfully, our a value is 1, so we can use our shortcut. Our shortcut tells us we go straight to our two factors. Set equal to 0. Our variable is u, and our blank is negative 3 and positive 2. So our two factors are u minus 3 and u plus 2. So coming up here, setting those two factors equal to 0. So u minus 3 equals 0, u plus 2 equals 0. Getting u by itself, we can add 3 to both sides. So we get u equals positive 3. Over here, we could subtract 2 from both sides. So we get u equals negative 2. Problem didn't ask us for u, it asked us to solve for y. So instead of u, I can plug in, because I know u is the same thing as saying 1 over y. So 1 over y equals 3, and 1 over y equals negative 2. All right, so let's try to get y by itself. 1 over y equals 3. It's 1 divided by y. So let's multiply both sides by y to get that y out of the denominator. Those cancel. We're left with 1 equals 3 times y. Now getting y by itself, we can divide by 3. So we're left over with 1/3 equals y. We got y by itself, so 1/3 is one answer. Same thing over here, 1 over y equals negative 2. Multiply both sides by y to get that y out of the bottom. We're left with 1 equals negative 2y. Dividing both sides by negative 2. We're left with negative 1/2 equals y. So y equals positive 1/3 and negative 1/2. So that's all. Yep. So this is all for 2.5a. Thank you for watching. You can now do 2.5a homework. If you have any questions, please let me know. If not, thanks again.